In this video, we're going to look at how we can eliminate the parameter when we're given a set of parametric equations. And if we start out with x equals t plus 2 and y equals t squared. So here we have our set of equations, and we want to eliminate the parameter, which means we want to get rid of the t. We want to come up with a rectangular equation in terms of only x and y. So to do that, the first step is to simply take one of the equations, and usually you want to pick the easiest one, and solve for the variable t. So I'm going to pick x equals t plus 2, and if we solve this equation for t, I'm going to subtract the 2 over, so we would get t is equal to x minus 2. Then we're going to take that value and substitute it into the other equation for t. So then we'll end up with y equals, instead of t squared, it's x minus 2 squared. And now we have eliminated the variable t. And that's what we wanted to do. We wanted to eliminate the parameter. Now we can leave it in this form, or we could actually multiply this out. We could leave this as y equals x minus 2 squared, or we could certainly square the binomial. And if we do that, we would end up with x squared minus 4x plus 4. And you would simply multiply this out. Now, let's look at this. We know that x minus 2 squared is going to be the graph of a parabola. And let's look at the t plus 2 and t squared and see if we come up with the same thing. So first of all, we're going to go to mode, and we are in parametric mode here. So if I go to y equals, I'm going to type in for the x, we have t plus 2. And then for y, we would type in our t squared. And I'll hit zoom 6, which is zoom standard. And we notice here we end up with our parabola. Now, if you notice here, we only have half of the parabola. And if we go into the window, it's because here our t minimum is 0. And we could certainly make that, I'll just pick negative 10, and we can see what happens. And we hit enter and graph. And notice there, when we pick some negative values for t, we actually get the entire parabola. And that's the same thing we would end up with if we looked at the graph of x minus 2 squared. We know that that's going to be a parabola. From before, the x minus 2 is going to move the graph 2 units to the right. So we would simply go 2 units to the right, and we would have our parabola. And that certainly does match the graph here that we got from the parametric equations. So once again, we simply took to solve or to eliminate the parameter, we simply take one of the equations and solve for t, and then simply substitute that into the other equation, and we come up with our rectangular equation in terms of only x and y. All right, for example number 2, let's say that we have x equals the square root of t and y equals 1 minus t. And once again, we want to eliminate the parameter. So we're going to solve one of the equations for t. And I'm actually going to pick the first one here, x equals the square root of t. So if we solve for t, I'm going to square both sides, so we would get x squared. And if we square the square root, that's going to simplify and cancel out, and we're simply left with t. So if we have x squared is equal to t, we now can take the x squared, substitute that in over here for t, and we would simply have y equals 1 minus x squared. Okay, so now that's the equation we have. Now we know this is going to be a parabola, and because of this, if I write it this way, we can maybe kind of recall negative x squared plus 1. If we graph this, we're going to end up with a parabola that is moved up 1, but it's going to, here the negative x squared is going to be a reflection down, so it's going to be up 1, and it's going to open down like this. Now let's see if we graph the parametric equations to see if we end up with the same thing. So here we'll go to y equals. We'll clear out the first one, and we would have the square root of t. And then for the y, we would have 1 minus t. And if we go to the graph, and if we notice here, we only end up with part of the parabola. And even if I go to the window, we have some values of t from starting at negative 10. And if we notice, we only have the right side of this parabola. And if we go back and look, why is that going to be the case? So here, this is the graph we're coming up with for the parametric equations. So this is the graph we're getting, but for the rectangular, we're getting the entire parabola. Well, if we look at the values of t, we have x equals the square root of t. In particular, if we look right here, we have the square root of t. Well, because we're taking the square root of t here, we're not able to take the square root of negative numbers. So that means we're going to eliminate all of our negative values over here, and that's why we only end up with part of the parabola. So in order for this equation here to match up with the parametric equations, we're going to have to restrict the domain so that we only get part of this parabola over here on the right. And to do that, we need to be able to eliminate this part, which means we have to eliminate all of our x values over here. So we have to restrict the domain of our parabola to values of x that are greater than or equal to 0. So when we eliminate the parameter, we have to be careful and realize that when we come up with the equation, we have negative x squared plus 1, but we have to adjust the domain in this case because we only want to end up with part of the parabola. So that when we graph a negative x squared plus 1, we're only going to get the right half, and therefore we eliminate the left half. And again, we do that because we cannot take the square root up here of a negative value, so the parametric equations are only giving us that half. Okay, let's look at one more example. And this one will be an example involving our trig functions. So we're going to have x equals the cosine of theta, and we have y equals 4 sine of theta. And now we want to eliminate the parameter, but you'll notice here we don't have a t, but the parameter in this case is the angle theta. So we want to eliminate theta so that we just once again have x and y. And to do that here, we're going to do something a little bit different. We're going to look at our trig identities, and in particular sine squared theta plus cosine squared theta equals 1. This is one of those Pythagorean identities, okay? And we're going to use this to help us to eliminate the angle theta. So first, I'm going to think of we have x equals cosine theta, and I want to think about over here how we can match this up with cosine squared. Well, if x equals cosine theta, if I square this, I can square the cosine by squaring both sides of the equation, and we would get x squared equals cosine squared theta. And then, of course, over here, if we have y equals 4 sine of theta, we could do the same thing. We could square both sides, and we would end up with y squared equals, now don't forget to square the 4 because we have a 4 here, so 4 squared would be 16 sine squared theta. And now we want to get rid of the 16, so we can divide that away, so we would end up with y squared over 16 is equal to sine squared theta. So if we look at these two here, we have x squared equals cosine squared theta and y squared over 16 equals sine squared theta. How can we use this Pythagorean identity here, sine squared plus cosine squared equals 1? Well, if we think of this here as our cosine squared, well, we can certainly think of that as simply x squared. And if we have sine squared, our sine squared is equal to y squared over 16, so we could say x squared plus y squared over 16, and then of course that is equal to 1. So here we have eliminated the parameter theta, and we have the equation in terms of x and y. And do you remember what this equation is, the graph of? Well, let's see. If we have x squared plus y squared over 16 and it's equal to 1 because of the plus here being equal to 1, this should be the equation for an ellipse. So now let's see if we can verify that by going back here and graphing cosine theta and 4 sine theta in our calculator. So if we go back to our x equals, and we're going to type in cosine theta. Now again, it's going to use t because we're in parametric mode, and that's perfectly fine. And we'll go down to y equals, and we'll type in 4 sine of theta. And then we're going to go to, I'm going to hit zoom 6, which is zoom standard. And you'll notice here we certainly do end up with an ellipse. So therefore, that verifies that this equation is correct. So once again here, to eliminate the parameter, the main goal is to take one equation, typically up here, and solve for t and simply substitute it into the other equation so that you strictly have your equation in terms of x and y. And in a lot of cases when you have parametric equations involving theta, you can think of using this over here, sine squared plus cosine squared equals 1, and get your trig function where you simply have cosine squared and sine squared, and then you can simply substitute in for sine squared and cosine squared and simply set it equal to 1.